Hey everyone, Sali is here. Welcome back to the channel. In today's video, we are diving into another important hook, which is useCallback. And I promise you, I'm going to cover everything you need to know about useCallback, even more than documentation. We will talk about how to use it, when to use it, and why exactly we need to use useCallback. We have some cool examples and scenarios which helps us to see useCallback in action. Then let's go. So before watching this video, make sure to watch my previous videos about useMemo and React.memo because I'm going to use both of them in this video. We're going to compare useCallback and useMemo. Then you need to know about useMemo too. And I'm going to use React.memo in one of the examples. Again, you need to know about React.memo too. I put the link of both of them into the description. Make sure to watch it, and after that, come back to watch this video. So what exactly is useCallback? UseCallback is a React hook which helps us to improve and optimize the performance of our application by caching a function. But why exactly we need to cache a function? Because in React, every time a React component re-render, it's gonna recreate all the functions inside this component again, a new instance of these functions. All right. Let's say we have a component and we have a function we named sum, and it's just gonna return 2 plus 2. At the first render, React will create a new instance of this function. And if you change something into this function, for example, a state or a prop or something else, React will re-render this component, right? And in the second render, React will create a new instance of this function. So now let's compare this function into the first render and second render. If we look at it, we can see that the logic will remain the same. In this render, the first render, we are returning 2 plus 2 into the sum function. And here in the second render, again, we are returning 2 plus 2. So what exactly is changing here? The reference and the address of this memory of this function into the memory. We know that everything in our application has a place into the memory, and that place has an address, right? In the first render, when React will create this function, React will put this function into the memory in some place, all right? And that place has an address, for example, 1x111. And if you change anything here, we have re-render. And in the second render, React will create a new instance of this function with the same logic, as you can see that, but with another address and another reference. Why? Because React this time will put this function in another place into the memory with another and a new address. All right? So now we know that between the re-render, for all the next renders, React when React will recreate this function, it's gonna keep the logic the same, but it's gonna change the address and the reference of this function into the memory. So, and this changing in the most of the cases is not a problem for us. We haven't ever noticed that, right? But in some cases, it could be a problem, and we can solve that problem by caching this function by using useCallback. And after doing that, React never gonna recreate this function again because we are reading this function from cache. Let me show you some examples for better understanding. Now I have a very simple application here, two pieces of states, count1 and count2. They both are numbers. And here I just display the values, as you can see that. And of course, we need two buttons to update these states. The first one to update count1. If I click on this button, it gonna goes up one by one. And if I click on the count2 here, the same will happen for it. All right, and I just put a console log here to show you how and when the parent component will re-render, and in the end of that, we have the child component. And let me tell you, there is nothing into the child component. I just put a log to show you how and when again the child component will re-render. Let's go to the browser to see how this works. If I refresh the page, you can see that yes, the initial re-render, we have it here. And if I click on increment 1, we are changing the count 1. We have the parent render and child re-render, right? And if I click on increment 2, again, we have the parent render and child render. So we need a re-render for parent component. Why? Because we are really changing something into the parent component. As you can see that we are changing count 1 or count 2. Then React knows that it must re-render the parent component. But I have a question. Are we changing anything into the child component? Do we have any state here and we are changing that? Or are we passing any prop here? Of course, no. So nothing is changing inside the child component, then we don't need to re-render the child component. We can use React.memo to prevent unnecessary re-render for entire component like this component, right? So it's really easy to use React.memo, but as I said, make sure to watch my main video about React.memo to help you for better understanding. But for now, it's just we need to wrap our child component with memo. Easy now. So after doing that, child component, this component here, never gonna re-render, never gonna force re-render by his parent again, unless a prop or a state or something really change inside it. Let me show you. If I refresh the page, it's initial render, right? Now, if I change count 1, you can see that we just have parent render. All right. If I change increment 2, again, we just have parent re-render, right? And child component never gonna re-render again by his parent unless a prop or a state or something really change inside it. For example, I can pass the count 2 as a prop here. Now we can see that if I go back to browser and refresh the page, now if I change the increment 1, it's gonna change count 1. Again, we can see that just parent render, but because we are passing the count 2 as a prop here, if I change count increment 2 and count 2 here, we can see that we have a parent render and child render. Because now we are really changing something into the child component, and React.memo knows that, oh yes, something is really changing, and I just let the component to re-render. All right. So till now, I just was implementing our base of our application scenarios that we need to use useCallback. All right. Till now, I'm gonna enter the problem. From now, I'm gonna enter the problem, and after that, we're gonna use useCallback to solve that problem. So now I want to show you the problem, but before that, let me ask you something. What exactly React.memo checked when we are passing count 2 as a prop here? Because we wrap the child component with memo, it only will re-render if this prop change. And because this prop is a state and the state has a value, right? For example, number 1, 2, 3, or more. If the value of this prop change, React.memo knows that the child component needs a render and let it to re-render, right? But what will happen if we pass a function as a prop instead of this state? We have a function here. You can see that, some function. And it's just going to return 2 plus 2. It's always going to be number 4. And I just want to pass it as a prop here instead of count 1. All right. And here into the child component, I just want to show the returned value from this component, from this function, some function. All right. So let me do that. We need a char here and here return it. Turn it. All right. Some value. Cool. So, and I just will call this function right here to show you the value of sum2. All right. If I do that, as I told you, if we pass a state here, because a state has a value, React.memo will check the value of the state and value of the prop. But when we pass a function as a prop, what exactly React.memo will check? The returned value, the logic of this function? No, it's gonna check the reference and the address of this function into the memory. And as I told you, every time a React component like parent component re-render, for example, if you change count1 or count2 or anything else, React will create a new instance of this function with the same logic, but with the different address and different reference into the memory. Because of that, React.memo always let the child component re-render, because all the time React.memo will see another address into the memory, another reference into the memory, right? Let me show you. If I refresh the page, and now if I click on increment 1, we can see parent re-render and child re-render. We can see if I click on increment 2, again we can see parent re-render and child re-render. We change nothing here, and some function never change. It always gonna return 2 plus 2 number 4, but because we are changing something here and this component re-render, it's gonna create a new instance of this function, and the new function has a new address, so the child component needs a re-render. But we don't need this re-render, and we can cache this function because nothing is changing into this function. We can cache it with useCallback, and we can read it from cache for the next renders and solve this problem. Now you may say, we didn't see any performance issue in our application. Everything worked very fast, as you can see that. So let the child component re-render. Yes, you're true. But what if our function, our sum function, was a very expensive function? Let me do that. I just put a for loop here, and there is nothing inside the body of this loop. I just execute this loop for 1 billion times. And now if I go back to browser and refresh the page, if I click on increment 1, we can see that we have a delay here. Let me show you my mouse. If I click on increment 2, you can see that we have a delay here, right? Now we need to cache this function because nothing is changing inside this function. We can cache it and read it from cache. With what? With useCallback. We need to import useCallback from React, and it's just gonna take two different arguments. The first one is a function, this function, and the second one is the dependency. All right, and I just can put this function, this arrow function, instead of this function, and useCallback will return the function for us. So I can again put this function here. All right, and I'm gonna tell you about dependency 2, but for now let's test this application again. If I refresh the page, now if I click on increment 1, we can see that it's just gonna return, it's just gonna render parent component. And if I just click on increment 2, again we can see that because useCallback cache this function, the sum function, every time for the next render, it's gonna read it from cache, and the reference, because React never gonna recreate this function again, it's gonna, the reference and the address of this function will remain the same, and that's what exactly we want. And now we just have the parent re-render, and everything will work very fast, right? So how about dependencies? Because for now we are just returning 2 plus 2, and it's always gonna be number 4. But what will happen if we use a dynamic things inside this component? For example, count2, a prop or state or something like that. Now we can't cache this function because we are using something dynamic here. We need to depend this function, useCallback, to count2, and we can do that with passing count2 right here to dependencies. And by doing that, useCallback always will cache this function until the count2 value change. If this state change, this function will execute and recreate again. Let's see that. If I refresh the page now, if I change increment 1, again we just have parent component, right? Parent re-render. But if I change increment 2 because we are using count 2 into the sum function. Now we have parent render and child render. Why? Because we depend this use callback, this function, to the count 2, and when we change it, again React will recreate this function for us, and again we have a new reference and a new address. So child component and React.memo will see a new address, so it needs a re-render, right? So now I'm going to tell you something which helps you to know where and when you need to use useCallback. When you have a very expensive function like this one, you need to use useCallback, and you are passing this function as a prop to a child component, right? Because you are checking the reference and the address of this function into the memory, so you need to cache it. The other use case is when you are passing this function as a dependency. For example, you have a use effect, use memo, or use callback, or anywhere you want to pass this function as a dependency. Use effect will check again the address and the reference of this function into the memory, and if the address change, yes, use effect will execute again. All right, and this was all the use cases you need to use callback in your application. Now I'm going to compare use callback and use memo. I pass same function to both of them. As you can see that return 2 plus 2, return 2 plus 2, and they are really similar because both of them are for optimizing and improving the performance of our application by caching a function, as you can see that. But there is a difference here. Use callback will return the function itself. Then you can call this function. But useMemo will return the returned value from this function and put it into this variable, right? I log it here to show you. If I refresh the page here, we can see that useMemo will return here for us a value. You can see that, but useCallback will give us the function itself. So we need to call it, right? It's really easy. If you want to cache the returned value from the function, you can use useMemo. If you want to cache the function itself, the reference and the address of the function itself, because you are passing it to a dependency or you are passing it into a component, you need to use useCallback to cache the function itself, right? So now you are a senior in useCallback hook because you know everything you need to know about useCallback, even more than documentation. If you enjoyed this video, make sure to subscribe my channel and leave a comment down below for me. And don't forget to join our Discord server. See you.